Hey everyone, welcome to today's Explainer. I am absolutely thrilled to guide you through a topic that truly powers our modern world. We're looking at Form 1 mathematics today, specifically Chapter 12, Data Handling. But listen, we aren't just going to memorize a bunch of boring formulas today. We're actually going to master the entire data lifecycle. I'm talking about from the very first moment you ask a question, all the way to analyzing the results and making sure those results are presented accurately. By the end of this Explainer, you're going to look at numbers in a completely different way.
Okay, let's dive into this visual roadmap of the 5 essential steps to handling data perfectly. We've got asking statistical questions, classifying and organizing data, constructing data representations, interpreting data and conversions, and finally, ethical data representation. Let's get right into it.
Step 1. Asking statistical questions. The genesis of data. So, you might be wondering, what exactly makes a question a statistical question? Well, it all comes down to one magic word, and that word is variability. Basically, a statistical question is just a question where you actually expect the answers to vary. You aren't looking for one single uniform fact, you're trying to collect a whole range of different answers that you can study. Honestly, variability is the heartbeat of statistics.
To really picture the difference here, think about this question. How tall are the students in Class 1 Bastari? When you ask that, you're going to get variability, right? One student might be 156 centimeters, another is 158, maybe someone else is 165. That is a statistical question for sure, because the answers vary. But if you ask, what time did you wake up this morning? Well, for you individually, there's literally only one exact factual answer. Maybe it was 7 a.m. Boom! No variability, no range of data to collect, just one fixed fact.
Moving on to Step 2, classifying and organizing data. Sorting the chaos.
Okay, so once we've collected all this messy data, maybe through surveys, interviews, or just direct observations, we have to classify it. Broadly speaking, it falls into 2 main buckets. First up is categorical data. This is all about characteristics and descriptive info. Think of things you can sort into categories. Like the colors of cats, blood groups, or what Class 1 Bastari likes for lunch, like chicken or nasi lemak. Then on the flip side, we have numerical data. This one's pretty straightforward. It just measures exact numerical information and numbers.
Now, the absolutely crucial point here is that if you're dealing with numerical data, you've got to break it down even further into 2 types, discrete and continuous. Discrete data can only take certain specific values, usually whole numbers. Think about it. You can't have 2.5 siblings, right? You have 2 or you have 3. It's counted. Continuous data, on the other hand, can take any value within a range because it's being measured. So a student's height isn't just exactly 156 centimeters. It could be 156.42 centimeters.
Step 3. Constructing data representations. Painting a picture with numbers.
Let's move to and see how this builds in practice. Say we want to construct a pie chart. You can't just draw slices willy-nilly. It's actually a very precise mathematical process. Step 1. You've got to find the angle of the sector for each category. Step 2. You draw a circle and divide it into sectors based on those exact calculated angles. Step 3. Label each sector clearly so it actually makes sense. And Step 4, this is super important, always write down the title of the pie chart.
To put that into perspective, here's a chart from a car dealer tracking the colors of dynamic car models sold. By calculating those angles, they can perfectly represent the portions of the whole. I mean, you can instantly see, without even looking at a single raw number, that red cars at 40% took up the largest slice of the pie. It's super effective. Pie charts are totally perfect when you want to compare parts to a whole.
But hey, pie charts aren't the only tool in your toolkit. You really have to choose the right chart for the right job, and understanding why is the key here. Bar charts. Fantastic for making comparisons between categories, like science versus math quiz scores. Line graphs are your go-to for tracking changes over a period of time, like a patient's fluctuating body temperature over 10 hours. Dot plots are great for seeing data distribution and spotting extreme, unusual values, like the duration of dental treatments from 17 to 25 minutes. Stem and leaf plots are a real game changer because they separate values by place value, like tens and ones, so you can see the distribution of, say, 20 students' math marks without losing a single original number. And histograms? They display grouped continuous data collected in class intervals, like the heights of 50 girls. Oh, and fun fact, if you connect the midpoints of those histogram bars, you get a frequency polygon, which helps us easily see the overall shape of the whole data trend.
Step 4. Interpreting data and conversions. Extracting the meaning.
Okay,
Let's look at this data table showing the mass of waste produced in a city in thousands of tons between 2010 and 2015. If we were to plot this on a line graph, we'd see a really distinct trend. The line would climb up, peaking right there in 2012 at 2,900,000 tons, and then it would clearly drop down each year after that. So we can actually make an inference here. The mass of waste produced decreased every year after 2012. Maybe the city finally started a massive recycling program. We can also do a little bit of math to find the mean, or the average. If we add up all those values, 1,900 plus 2,100, all the way down to that 1,600, we get a total of 13,200,000 tons over the 6 years. Divide that whole shebang by 6, and boom, our mean mass of waste is exactly 2,200 tons per year. That's how these charts give us the raw material to find some really powerful insights.
Now, data isn't just locked into one format. You can actually convert representations. Say a community polyclinic tracks patient pulse rates on a stem and leaf plot. Well, you could flawlessly convert that into a dot plot. Why? Because both of those representations beautifully display numerical data distribution while entirely retaining the exact original data values. It's really all about choosing the presentation that makes the information clearest to whoever's looking at it.
And that brings us to step 5, ethical data representation. Spotting misleading math. Now, what's really interesting about this slide is, think about this scenario. Adam scored 14 football goals and Ravi scored 10. Obviously, 14 is not twice as big as 10, right? It's just 4 more. But what if you look at a bar chart in the newspaper and Adam's bar looks literally twice as tall as Ravi's? Does a bar chart make Adam's score look twice as big? How is that even mathematically possible?
Well, here is the secret to spotting misleading math. A bar chart is incredibly misleading and honestly totally inaccurate if the vertical axis scale does not start exactly at 0. If the chart starts at, say, 8 instead of 0, Ravi's 10 is going to look like a tiny sliver of just 2 units, while Adam's 14 looks like a massive, towering 6 units. It visually exaggerates the difference and entirely confuses the reader. Always, always check that the axis starts at 0.
Here's another classic trick you've got to watch out for. Imagine you're looking at a pie chart on a math test, and you add up the percentages of all the slices. Say they're 22%, 36%, 28%, and 10%. The total? 96%. Guys, this is a mathematical impossibility. Because a pie chart represents a complete whole, the total percentage of all those sectors combined must always equal exactly 100%. No way around it. If it doesn't, that data is totally flawed.
So, as we wrap up, remember that understanding Form 1 Chapter 12 isn't just about passing your next math test. Although, quick revision tip, always double-check if your data is categorical or numerical before picking your chart, and label those axes. But really, it's about becoming a sharp, critical thinker in a world that is just overflowing with data. You now have the tools to see things clearly. So, I leave you with this final thought. When you look at the charts scrolling by in your daily life, are they telling you the whole ethical truth, or just the part they want you to see? Keep questioning, keep analyzing, and we'll see you in the next explainer.